Hey everyone, so here's the second week 3 lab, which is the properties of water. Hopefully you have your lab pack hands-on kit and manual and everything, so this isn't a problem. Table 6, as you noticed from the discussion, is going to be something you probably want to share. And as always, we have the formatted lab and the rubric to look at. Let's look at the rubric first. Hello. So let's look at this rubric, and then I'm going to almost be done with videos for today. I'm only going through the end of week 3 today. I'll do the rest of them later. You should hopefully have walkthroughs of everything way before it happens. Alright, so this is a standard rubric, as you can tell. It looks like exercise 3 and 4 are a bit heavier, so they're worth a little extra, and then it's half a point for format and citations. And again, you will probably have to do some pictures or something since it talks about that. Let's walk through the lab. Again, I'll be looking at my key, so if anything seems a little bit pausy, it's because I'm checking the key. Let's open that sucker. Okay, so as always, create your title page first, so it's all pretty and we have that title page. And then we're going to have no observation section, which just feels so weird. We're going to state our hypothesis, so it's what we're going to be able to test. Make sure it's something you can test, right? And then in here you'll have your different trials, your paper clip, did it float, try it compacted, try it with detergent, just for fun. It says detergent is optional in the original version, but just do it. It doesn't take any effort. It's fun. Fun, fun, fun. And I may have a weird idea of fun, but deal with it. Okay, then we have, does the weight affect it, does the size affect it, does the shape affect it, does detergent affect it? So then we talk about why you need everything to be clean, and was your hypothesis refuted or supported. That should be pretty logical, right? Not too scary. Give 2 examples of surface tension of water when it's important. If you need to, this is a good place to use in-text citations and an outside resource, or if you think of off the top of your head, that's fine too. Would other liquids have the same surface tension property? Why or why not? And how do you think like a paper clip would handle an olive oil? Is there a limit to the tensile strength of the water surface? Explain it. So don't just answer yes or no. Explain. And what are some experimental variables that are important to consider? What was the purpose of this exercise? So as always with purposes, I would scroll back up and be like, what was the name of this? It was surface tension. Purpose is probably something to do with understanding surface tension. Just thinking. I know I'm in a snarky mood today. Anyways, capillary action, next one. So we have our hypothesis and what do you think will happen? And then we have a table. You say what it is, what the height of it is. Then we do, make sure you measure that internal diameter. It's not from the outside, from the inside to inside. Record the results. This is one you'll probably need to share. I forgot to add this into the thing. Share. If you notice this, just share it. Share it. Oh, what is that? See? I'm going to look at it now. Results, exercise 2. Results C. So we're going to pause for a second. Aha, that's now updated. Okay. Oh, there's your in. And that's where you had it in, right? And then we make a graph, take a picture, whatever it looks like. And then from my data, blah, 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 is recorded in blah, blah, a different line of somebody else, okay? That fun stuff. And then we're going to have some questions. What did you observe? What was the outcome compared to other people? How does it explain it to your hypothesis? Give 2 examples of capillary action of water that's important. If you can't think of anything, outside research. What other liquids have this property? I would probably have to do outside research. Well, I have the answer key, so I don't. But you might want to do that. Blood does kind of the same stuff. See, it gives you like one of them. Why does blood pressure rise with this disease? I would probably look that up. And then counter it. In plants, they have this. Didn't just answer your question. I hate it when it does that. Is it harder to suck up a beverage through a small diameter straw or a large diameter straw? That sounds not so bad. And what was the purpose? Check your title. So then we're on to density. I scrolled everything up. Hypothesis. Record what happened. So what happened? What did you observe? How did outcome compare? Was the support refuted? Why is it important that ice floats? I think they talk about this a lot in the book too. Right now I'm not sure because my brain is thinking of an image from Facebook about how like under an iceberg that you can't see is like all the information the book would have given you, but the little parts you can see is like the movie. Yes, my brain works weird. So then 2 examples of this property important. Do all solids float? What's the density? The density of olive oil is like whatever. What can you say is solid olive oil? Will it float or sink? Attempt it with another pure substance in this form, blah, blah, blah. Okay, so attempt to find another pure substance like water or oil in which the solid form floats on the liquid form. So this is something like, try Google, look it up. Don't spend a long time on this. It's trying to show you something very specific, which you should get across really quickly. Okay? What did you learn? Hopefully about density. Specific heat capacity. So state your hypothesis. What's the difference in the heights? Record what happened. Look at the beautiful thing. Graph the sucker. Calculate your rate. This is where, again, you're sharing it with the other students, right? So you can fill in this one. And it says to post all that up there. Anytime it says share with other students, if I didn't already put a post up there, stick it yourself and tell Heather, me, that I forgot to do it. Because, yeah, I'm not perfect. I try to be. And if you let me know, I'll correct it, add it in, and then the next class will be better. So you're just helping the future. Isn't that how it always is? We're going to plot everything. We did that. What our melting rates are. What would you conclude? What experimental variables are important to consider when doing this exercise? How might you design a similar experiment with specific heat? Come up with some options. I want to see if the thing gave me any good options to mention. I've been lazy about scrolling. Here we go. You have to think about what you could put into some, to either watch it cool or watch it heat up is kind of what we're going with. Maybe with an ambient temperature. Okay, and then alternative energy. This is the one I like. I like this one. And decide water or oil. You're going to want to look specifically at your melting experiment and which one can hold more energy, and then do our summation. Hopefully this helps and was somewhat useful and I wasn't too random. Enjoy.